In the field of science and huge mysteries, the subject of what existed prior to the enormous explosion has sparked mixed conversations and fascinated thinkers for quite a while. This huge question doesn't just test how we could decode the universe, it poses a challenge to the actual boundaries of human knowledge. Imagine yourself at the brink of existence, looking into the colossal unknown, observing and pondering the contents before our universe was imagined. The event of the Big Bang marked the beginning of time, space, and all that we know. Anyway, was there a second earlier? Previously? Could there have been a condition of nothingness, a calm before the cosmic gathering began? And if this is accurate, maybe there was something much more alarming that existed previously, before time itself. As we continue with this inquiry, science takes us on a journey past the universe's beginning point, into thoughts that challenge our consciousness. Physicist Brian Cox, known for his investigations into the wonders of the universe, suggests that something surprising might have existed before the massive explosion. He directs us to reconsider our concept of reality and existence. In this investigation, we dissect the theories, the research, and the dazzling insider secrets that might make sense of what existed before it all. We'll explore ideas like self-organizing development, quantum changes, dark energy, and even multiverses. The answers we've revealed might just paralyze you, yet they could also open new understandings of our position. Prepare to plunge into the depths of the universe, into a realm that defies imagination and science. Amid the obscure, among scientists left in the shadows, floored and sometimes even upset, we ought to explore what existed before the Big Bang, and why these theories challenge all we thought we knew. To appreciate what may have existed before the Big Bang, we must first painstakingly analyze what the Big Bang was. The Big Bang, according to scientists, refers to the moment when the universe became extremely hot and dense, growing rapidly to set off the development of all matter, energy, and boundless forces. When we look toward the night sky, we see proof of this hot beginning, with galaxies spreading out this way and that from an early starting point. But why did this happen? Furthermore, was there a period before this dense, hot start? As indicated by the theory of cosmic inflation, there was, without a doubt, a before. And it was not even close to void or peaceful. Vast expansion suggests that the universe existed before the Big Bang, a state that was cold, vacant, and loose. Basically, it resembled a huge vacuum. Anyway, this vacuum wasn't entirely unfulfilled. It contained a tremendous amount of energy that fueled the quick expansion of space itself. This expansion, called inflation, happened so rapidly that it basically established the foundation upon which everything else would be laid. In a fraction of a second, space extended at unfathomable rates until the expansion slowed down and the energy transformed into matter, like atoms and the forces we recognize today as the Big Bang. But what was the nature of this energy? Why did it suddenly grow the universe? And why did it stop? Specialists believe that this cosmic expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric extending endlessly, forming tiny air pockets here and there. Each air pocket represented a universe, including our own. This idea, called the inflationary multiverse, suggests that there are possibly Big Bangs with no limits, an infinite number of universes. Our own is just one of many. This enormous, perplexing reality challenges our understanding of the very universe itself and leaves us with a question. What else is out there? The idea that before the Big Bang is nothingness is speculative, but not confirmed, according to our current understanding. Regardless of whether you eliminate all energy, radiation, and particles from the universe, it would still not be truly empty. Darkness fills the void in our universe. Matter, quantum fields, and dark energy, along with other forces that weave an inevitable structure embroidered with something, even in its most empty state. Even if we could imagine removing everything, these forces leaving a dead space, the universe would still generate new kinds of energy. This reality alone is bewildering to specialists, as it suggests that true nothingness might be impossible within our infinite comprehension. Space itself has properties, rules, and constants that prevent it from being totally empty. Imagine creating a region with literally nothing in it. No particles, no radiation, and no energy, except quantum fields and major constants. These would still exist, suggesting that this nothingness has properties. For example, there is a phenomenon called zero-point energy, which represents the lowest possible energy condition of quantum fields. In this state, particles can still momentarily appear and vanish, creating a spooky resonance of movement, even in what should be empty space. This challenges our idea of a real void and suggests that, yes, even before the Big Bang, there was something that scientists are only beginning to understand. One of the most astounding theories in current cosmology is the possibility of timeless expansion. If inflation were the reason our universe exists, it's possible it could continue forever. Brian Cox describes an astonishingly vast inflationary multiverse, where universes are infinitely created and continue expanding. Imagine each Big Bang as a flash, lighting another universe, while inflation continues in different areas, transforming into numerous other universes. This cycle could, in theory, go on for eternity. This idea of vast universes gives birth to an enchanting concept of a fractal universe, where each new universe might actually create its own Big Bang. Every universe exists as a separate, independent domain, unaffected by the others because of the rapid expansion of space. This hypothesis provides something to researchers that is both exciting and unsettling, as it suggests a never-ending multiverse, with no definitive beginning or end. Imagine our universe being just one bit in a giant cosmic structure, forever expanding and constantly making new universes. And what if the real twist is that there is no before or after, but rather a timeless pattern of universes forming and decaying? How we interpret nothingness changes when we consider how quantum field theory works. The universe is not just an assortment of matter floating in space. Instead, it's a complex energy network, fields that fill the universe, connecting to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, momentarily acquiring energy before returning it. This phenomenon results in substances that resemble virtual particles, which immediately exist and then vanish, leaving only a faint memory of their presence. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have nothing to do with this? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes creating transient particles. This constant movement in what should be nothing implies that the universe does not acknowledge our notion of emptiness. The fields and forces continue to fill the universe with hidden energy, energy that prevents absolute nothingness. This understanding raises an intriguing question. If fields make particles, and the universe could be made of particles, then could matter itself have emerged from this nothing? This nothing, filled with dark energy from quantum fields, is an unidentified force that drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? Some theories take into account the fact that dark energy exists today as a leftover of an energy field from before our universe's development. The properties of dark energy seem to suggest a colossal hidden force that might have existed in some form prior to the Big Bang. Some theories imply that dark energy existed in a much stronger state and could have controlled the inflationary stage, causing rapid expansion. Dark energy's presence suggests that, regardless of whether our universe were exhausted of all matter and radiation, this force would persist, expanding the fabric of spacetime. A troubling question emerges from this thought. If dark energy was present before the Big Bang, could it have formed the circumstances that led to the birth of our universe? Could dark energy be the unnoticed creator of inflation, or even the actual moment when our universe began? As we explore this possibility, we face the idea that dark energy is not only a force shaping our universe, but a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. The idea that the universe goes through endless cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event, but rather part of a timeless rhythm where universes expand, then collapse, and regenerate in another cycle. This theory suggests that our universe might have been reborn from the remnants of a past universe. The process of contraction and expansion would entail that there was never a true beginning, just an eternal series of universes growing and changing themselves cyclically. Cyclic cosmology raises significant questions about time, as it suggests that time itself may be cyclical, as opposed to linear. If this theory is correct, it could mean that what existed before the Big Bang was just another version of the universe, one that collapsed only to give birth to the universe we have today. For researchers, this theory offers a rich answer to the question of ultimate origins, proposing that there is no true beginning. Since its inception, the universe has existed in some form, transcending our ideas of time and existence. Early-stage gravitational waves are another intriguing idea that could hold hints about what happened before the Big Bang. Gravitational waves are ripples in spacetime caused by massive cosmic events, and scientists believe early-stage waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as the echoes of what came before the Big Bang. Should they be identified, they might provide proof of the universe's previous iterations. The possibility of discovering early-stage gravitational waves is one of the most exciting in cosmology today, as it might not only reveal the truth about the Big Bang, but also offer a glimpse into the cosmic state before our universe was born. This theory offers a tantalizing prospect, detecting gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what could have existed before the Big Bang, we delve into concepts that push the boundaries of our understanding, challenging even our most fundamental assumptions about space, time, and existence itself. One of the most mind-boggling ideas comes from the study of quantum gravity, which aims to merge quantum mechanics with general relativity. This merger could potentially reveal a unified theory of everything and might offer insight into what existed prior to the Big Bang. Quantum gravity suggests that space and time are not smooth, continuous entities as we experience them, but instead are discrete, granular structures. This theory posits that the fabric of spacetime itself could have originated from a microscopic Planck-scale structure, with tiny quantum changes shaping the universe in ways we cannot yet fully comprehend. In this view, what we perceive as the smooth continuum of space and time might have only emerged from these fluctuating quantum fields. Thus, before it was possible to describe the Big Bang, there may have been a radically different concept of reality, one where space and time themselves were not fully formed. Another possibility is that the universe is part of a vast cosmic landscape of possible universes, each with different physical laws and constants. This theory, known as the string landscape, arises from string theory, which holds that all fundamental particles are actually tiny vibrating strings. In this framework, there are many possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape could imply that our universe is only one of many, emerging from its own distinct Big Bang-like event. The existence of such a landscape also brings forth the notion that other universes might have different dimensions, different strengths of gravity, or even different types of matter. In this view, our universe might not be unique but rather part of a collection of universes called the multiverse, each evolving independently. The multiverse theory provides a speculative yet intriguing response to the question of what came before the Big Bang. Another universe, in a different configuration, potentially leading to infinite cycles of creation and destruction, with no definitive origin. In addition to these cosmological models, some theoretical physicists have also considered the role of black holes in determining the character of the universe. A hypothesis gaining traction is the idea that our universe may be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another universe, with the Big Bang being the moment when such a black hole gave birth to our cosmos. This hypothesis is supported by the fact that, according to general relativity, the singularity at a black hole's center is a point where space and time curve infinitely, creating a region where the known laws of physics break down. It's possible that the extreme conditions inside black holes could lead to the creation of new universes, which may suggest that what we consider the Big Bang was just the birth of our universe from the singularity of an ancient black hole. Exploring these concepts necessitates a thorough investigation of the very nature of time itself. Some cosmologists speculate that time, as we recognize it, might not have meant anything prior to the Big Bang. Assuming that the Big Bang was the beginning, then there may have been no before in any standard sense. According to this view, time itself might have emerged from a quantum fluctuation or from an relies on the assumption that events happen in a linear sequence. If time did not exist in the way we experience it, then the question of what came before the Big Bang becomes absurd, because there wouldn't be any temporal framework to support it. Further complicating the picture are theories of cyclic time, as mentioned previously. Cyclic cosmology suggests that the universe undergoes endless cycles of birth, evolution, and eventual collapse. In this model, the Big Bang could represent just the most recent bounce in an eternal series of universe cycles. These cycles might not be identical but could evolve in different directions, each with unique physical properties. In this theory's view, the universe would be a continual process with no true beginning or end, rendering the question of what came before the Big Bang meaningless in the conventional sense. The idea that time itself might be cyclical suggests that every Big Bang could be followed by a contraction, with the universe relaunching itself in a never-ending loop. Another avenue of investigation into the nature of the cosmos is the potential of a primordial soup of particles and fields that existed before the formation of stars and galaxies. This concept suggests that, before the universe began its rapid expansion, it was filled with a dense and hot mixture of elementary particles, including quarks, leptons, and bosons, all in a state of extreme energy. There would have been interactions between particles at extremely high densities and temperatures, laying the groundwork for the formation of energy and matter. As the universe cooled, some versions of this theory suggest that this primordial soup existed in a place where quantum foam and particles kept appearing and vanishing due to the uncertainty principle of quantum mechanics. The properties of the soup could potentially offer insights into the universe's beginnings, and, by extension, what preceded the Big Bang itself. Ultimately, the world before the Big Bang remains one of the greatest mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics improves, new hypotheses will continue to emerge, offering increasingly complex and sometimes paradoxical explanations for the origins of our universe. While we may never fully grasp what came before the Big Bang, the pursuit of this knowledge will continue to stretch the limits of human curiosity, driving us to explore the unknown frontiers of existence.